Hi everyone, welcome to another Learning at Lambert Labs. Today's presenter is Millie, so I'll hand over to Millie.
Cool, thank you. My name's Amelia Crowther, and I'm going to be talking about automatically generating SQLAlchemy models from database code. So I think it's best to start this discussion with a formal statement of the problem. And I guess one of the things that you have to deal with when you're writing ORM code is that you have to create a lot of Python classes, which are, each of them are essentially representations of tables in your database. And one of the problems this generates is that you have, I guess, two sources of truth to describe what the structure of the database is. And on like the most basic level, this just means you do twice the work. Like you have to write out the DB schema, then you have to write out the ORM schema. But then it also produces some sort of problems with version control. And, whenever there's like duplication of work in software, duplication always leads to the possibility of introducing errors from like the discrepancies between your two schemas. So like that isn't like to be a massive problem because like I think there's only so far that the SQLAlchemy schema can diverge before it starts causing problems. But even then, it would be easier to just have a sort of one-to-one mapping, and it doesn't seem impossible. So one thing we can talk about is one of the existing solutions to this problem, which is the Alembic package. So this package was created by the author of SQLAlchemy, and it's a tool for managing database migrations based on SQLAlchemy. So effectively, based on the SQLAlchemy models you have in your Python code base, it can create scripts or just like emit a list of SQL statements to manipulate your database to fit the SQLAlchemy. So if you think about this, it's effectively manipulating the database so that it matches your SQLAlchemy. So your SQLAlchemy code becomes the one source of truth, which the database is changed to fit. And this is like a very good solution to this problem. The only con is that it requires you to be able to update the database schema whenever you want. And in most situations, you should be able to do that, but it's quite possible that you may find yourself in a situation where you're not able to update the database schema. So there is another solution to this problem, which is the SQLAlchemy code gen package. Now, this is like effectively the inverse operation of Alembic. So what it does is it takes the database, it reads from the database, and then generates SQLAlchemy models from the database. And one of the ways that this is different to Alembic is that it only requires read access to the DB, because in this scenario, it's the database that becomes the database that becomes the one source of truth, and then the SQLAlchemy code is modified based on the database. And in some ways, that's more intuitive because, well, it seems like the database is like the lowest level and of like data representation, and it sort of makes sense to build off that in your Python code. But I think both these solutions work well in different scenarios, I'd say. Yeah, so the SQLAlchemy code generation package, it takes a DB, a connection to a DB, and then it produces a full model, and it produces like a ORM table for every table in the database. And as well as this, it can like automatically detect SQLAlchemy relationships based on like the foreign keys that are in the different tables. And most of the time, it's going to generate these in the class form of SQLAlchemy table that we're used to. That as a sort of fallback, it may generate this sort of raw table format you can see at the bottom, which I guess if you use SQLAlchemy, you're not as used to seeing. But this is only in a couple of circumstances. Like if the table doesn't have a primary key, then it will use this fallback scenario. But actually, SQLAlchemy requires you to use primary keys, so that's not really an important situation. And then the other scenario is if the table is an association table. So that means if it's essentially just a link table between two others, and the criteria for that are if it has exactly two foreign keys and no other fields. So in that scenario, it won't generate a full table in the class style that I guess we're more used to. But instead of that, it will just create a many-to-many relationship. So it's essentially just detects the relationship and puts it on both of the linked tables from that association table. So it's quite likely you wouldn't need to directly refer to that association table anyway. So it's not the end of the world if it doesn't have a like a fully featured class table. So yeah, let me show you what this looks like. So I've got a simple database here. We've got one table, which is just the users in the database. And each user has a primary key and they have a username and an email. So it's a pretty simple table. I'll just take this and I'll put it into my DB. So I've made a table. You can see there's the users table, the only table we have at the moment. And if I describe the users table, it's got a primary key and it's got a username and an email. So if I run my codegen script, and the codegen script is quite simply calling SQLCodegen with the URL to the database. So it's quite simple to use. And if I call this script, you can see it's produced the user table based on the users table in the DB. And you can see that the ID field is present with the set as a primary key and with the auto incrementation in serial set, as well as the username and email fields. You might also notice it's automatically set the name of this table, which I thought was quite clever. It's clever enough to like change the plural form into a singular form, and then it capitalizes the first letter in the table name. And I think if there's underscores in the table name, it also like removes them and capitalizes them so it's in the right case. So for a simple table like this, it's very convenient and works very well. But also, if I add this second table, so this second table is to store a user's documents. So it also has a primary key in the form of an integer, and it has a document title and the contents of the document, as well as a foreign key from the document to the user, denoting like which user owns this document. So let's go. So then we've just created our document table. You can see we've got two tables now. And this is quite similar, to be honest. We've got the primary key, the title, the contents, and the only difference is we've got this additional foreign key constraint at the bottom linking to the user table. So if I run my codegen script again, you can see we've got the user table as we did before, but we've also got the documents table that's been generated, and it has the usual fields you expect, including this foreign key here, but it also has automatically generated this user relationship as well, which is very useful because if you're not familiar with SQLAlchemy, this allows you to, instead of performing a lookup based on foreign keys, it allows you to just directly access the user object. So it's a very convenient feature to have. Let me go back to the. So how can we integrate this into our build process for our application? There's only one catch relative to like a normal or like a manual SQLAlchemy setup, and that's that. So your SQLAlchemy models are based on the data that's in the DB or the structure of the data that's in the DB. So this means that in order to generate this code, your database needs to already be up and running. And your database needs to be up and running before you start executing your Python code, because otherwise you're just not going to have the Python code generated and your app isn't going to build because it's trying to use code that doesn't exist yet. So your process needs to be that you start the database first, you wait for the database to be up, then you run SQLAlchemy codegen to generate the Python code you need. And it's only then that you actually start your Python app. So if I look at my test program I've got here, this just does some quite org standard like SQLAlchemy queries. But it's trying to import the user and document tables from this file that I called AutoSQLA. And obviously these don't exist yet, right? So there's import errors and this like file is not going to build. So what we can do is we can run the codegen script, but we can put the output into this file autosqla.py. And that's going to create a new file here with all of our SQLAlchemy tables in it. And if we look at the program, you can see that obviously now the import errors have been fixed. So if we're writing our build script, what we can do is, well, first of all, we have to ensure the database is already running. I haven't put that in this script, but you essentially need to wait for the database to start up and wait for it to be responsive. But that's going to be your first step. And then your second step is going to be to generate the code and store it in some Python file. And it's only then that you run your test program. So I'll walk you through this test program fairly quickly. I mean, it's quite straightforward. All it does is delete existing data, and then it adds 3 users with different names. And then it adds 3 documents, each of which belong to their corresponding user. And if you look here, you can see that we're actually using the relationship here. So instead of doing, I guess we might have to do something like this. All users, something like that. Because these relationships being automatically generated, we can just use the user field directly. So yeah, this program, it just creates 3 users, and it creates 3 documents and links each document to its corresponding user. And then it's, yeah, and then it prints out the username of each user and the title of each document. Great. So I'm going to delete that generated code just to make it clear how it works. So you can see we've got our import errors, that the code doesn't exist yet. And if I run my build script, it's going to generate the SQLAlchemy code and then run the program. And there we go. As you can see, it's like printed out the name of each user and the title of each document. So I think that's a sort of quick demonstration as to how this could be integrated into your existing app. And then last up, I'd like to talk about maybe some of the disadvantages of this approach. I think the first of these is that there's a lack of fine control over the code that's generated. So yeah, so the one that I noticed missing is backrefs in relationships. So if you've written SQLAlchemy code, you might have done something like this. And basically, what this does is it makes the relationship referable in 2 ways. So with this existing generated code, I can, let's say I have my document. I can quite easily refer to document.user, and this will give me the user that owns a given document. And if I had the backref, I could also do user.documents, right? And this would give me a list of documents that belong to a given user. But as far as I can tell, this backref parameter isn't automatically generated by this package at this time. So it feels like that's a missing feature, because I've definitely used this backref parameter quite a lot when writing SQLAlchemy code, and would be good to see that included, I guess. The other one is there's not as much control over class names. So I actually thought that the generation of class names was quite good. especially given that it manages to like convert plurals to singulars and like properly capitalize names. But let's say you've got a perhaps like poorly named table in your database. Like let's say this was called like udocs or something, user documents. It's not very clear, and this would be automatically converted into, I think, udocs like, or udoc like this. And I guess this comes with the territory for like auto-generating code, but really it would be nice to not have that poor naming scheme propagate out to the SQLAlchemy model, and it would be nice to actually be able to choose a better name in Python. And then the last feature I think that I would miss if we did this approach was like the use of custom properties. So I've certainly done this a lot of times before, where you write a property of some kind based on SQL, based on a relationship or something like that. So something like this, where you could just add like a small custom property to a class, or like even a helper method of some kind. You know, there's just a lot less customizability on the actual generated code, which I think that might be missed or something. But then part of using auto-generated code is that the emphasis is taken away from the actual SQLAlchemy code itself. So maybe this functionality would just have to be moved out of SQLAlchemy into higher up into the Python application. And then another disadvantage of this approach, I would say, is that its portability seems to be a concern. Like this is something I noticed while working on this example, because I generated this code from a PostgreSQL database, and I don't think that this code would then be usable with another database, for example, MySQL. And I say this because, so I've set an auto-incrementing primary key, and in Postgres, it has this default value of next val here, and also the same on the users table, next val here. And this is then, if you look at the Python code, this is then being propagated up to the default values here and here. And I think if you try to run this SQLAlchemy code against a MySQL database with like the same structure, it would not function correctly, I don't think. But then it's debatable whether this is a disadvantage, because since we're auto-generating this code, if you actually did have a MySQL database, you could just regenerate this code instantly, which would effectively get rid of this problem. But it does create a certain dependency. Necessarily, it creates a dependency on the actual type of database, as well as the database itself. But that's everything, I think. Are there any questions?